Before we start on this chapter where we're going to really look at exponential functions, I think it's necessary to take a step back and make sure that we're comfortable with some of the basic properties of exponential expressions. So we're going to just review these. These would be things that you would have encountered in a beginning algebra class, an intermediate algebra class. And so we just want to remind ourselves of some of these things here. So first and foremost, if I take a variable or a number and I raise it to the 0 power, that's always going to equal 1. So we'll call that property number 1. Number 2, if you are multiplying like bases together, and they each have an exponent, then you can combine them by adding the exponents. And that, that makes sense because, x squared times x cubed, we know that that should be 2x's multiplied here, 3x's multiplied here, so that would be a total of 5x's multiplied together, so you can see how that works. Number 3 is very similar to number 2. If we're dividing those like bases, then we subtract the exponents to combine them. Now you can do it one of two ways. You can subtract the bottom one from the top one, like right here, and that gives you x to the m minus n. But if you want to subtract it in the other order, then you can do n minus m, but then that expression is in the bottom of the fraction, right? And just to kind of see why this would make sense, if I had x squared over x to the 5th, right? 2 of the x's up here would cancel with 2 of the x's down here, leaving you with what? 3x's multiplied on the bottom and just a 1 on top. Okay, so that's what that's saying. Now, if I have a power raised to a power, we'll call this property 4, then you simplify by multiplying the exponents. Okay, so if I have x cubed squared, okay, well, what does that mean? That means x cubed times x cubed, and we already know we're supposed to add these, right? So x to the 6th, you can see 3 times 2 is 6. Number 5, if I have a negative exponent, the definition of that is that that's the same as 1 over x to that positive exponent. And if you start with the negative exponent on bottom, you can bring it up in the fraction and make it x to the n. So the way in my mind that I like to think of these two is when you want to change the sign of the exponent, you change the level that that particular value is on. All right, and then we look at these two here. We'll call these 7 and 8, and they're just saying if you're either multiplying two things or dividing two things first and then raising them to the power, you actually could have raised each one individually to the power and then multiplied or then divided. And then lastly, this property is one that we talked about a little bit earlier in the quarter. But what does it mean to have a fraction in your exponent? Well, if you have a fraction that looks like 1 over n, that's just going to be the nth root of x. And then if you have something besides 1 in the numerator of the fraction, then that would be the nth root of x to the m power. Or you could also do it this way, the nth root of x all raised to the m power. So you can do that in either manner. The catch is you got to make sure that fraction was simplified to begin with. So let's do a couple of examples here. All right, so what we're going to do first is we're going to simplify this. I'm going to simplify 3x cubed y to the negative 5 c to the negative 2 divided by x y to the negative 2, and we're going to raise all that to the 3rd power. All right, so how do we simplify this? Well, we take a look at our properties here, and we figure out, okay, what kind of properties can I use to make this simpler? And the fact that I have an x on top, an x on bottom, a y on top, y on bottom really draws me to number 3 right here, right? The fact that I can subtract exponents in order to combine like base division. All right, so let's start with that. So in this first step, I'm not going to do anything with the number 3, so let's just rewrite it. Now, this x on the bottom is really x to the first power, right? So what I can see is that I can take x to the 3 minus 1, and that combines this according to this property here. Now, if I look at the y's, I could do the same thing. I could say -5 minus -2, which would be -5 plus 2. But if I do that, I end up with y to the -3rd. And when we simplify expressions like this, we really don't want negative exponents in the end. So we remember that we can also work with the property this way, where I bring it down and have the one that's on bottom, n, minus the one on top. And so if I do that in this instance, and I say y to the -2 minus -5, then that's going to yield a positive exponent in the end. So I might as well do that in that manner. And then the z to the -2, right, it's all by itself. There's no other z's in the expression. So then that makes me think more like number 5 here, where we say, all right, if I have a negative exponent, I can make it positive if I just change its level in the fraction. So I take this z to the -2, I send it down, and it becomes z squared. And of course, all this is still raised to the 3rd. So I used a combination here of 3 and 5 in my first step. All right, now let's clean things up a bit here. So this is 3x squared. Down here it's -2 plus 5, so y cubed, and then z squared on bottom. Okay, now where do we go next? Well, here I have these properties that say if I'm multiplying and dividing different numbers, variables, etc., and I'm raising all of it to the power, then I am allowed to take that power to each one of those individually. So for each of these, I'm raising them all to the 3rd power. Now that 3 to the 3rd power, right, I can pull out my calculator and see that's 27. That's one you can do in your head though. But what about these other ones? Well, these all look a lot like property number 4 here, right? So we know if I have a power raised to a power, it's time to just multiply those exponents. So in the end here, we get 27x to the 6th over y to the 9th, z to the 6th. All right, and that would be our simplified expression. All right, so all I'm trying to do here is just kind of exercise those simplification of exponents muscles again, because we're going to have to use some of these skills, right? I'm not going to ask you any problems that are specifically going to look like this, but you're going to have to use some of these skills here and there as we go through the chapter. All right, let's take a look at one more. I think I can fit it down here. Let's simplify -3 square root of x cube root of y squared to the 4th. Okay, so if this is what we have, remember that we can transfer this into exponent language so that I can use my exponent properties. So remember that anytime you have the root without a number here, there's really a 2 there, right? So there's a 2 hiding out anytime there's one missing, because it's the square root. So I end up with -3 x to the 1/2, and then y would be to the 2/3, right? And we're all raising that to the 4th power. Okay, now when I raise that to the 4th power, I know that I'm multiplying all those, so each one can individually be raised to the 4th power. And a good thing just to remember here is that when you take -3 to the 4th power, you're taking a negative times a negative times a negative times a negative. So that's going to be a positive 81. And then 1/2 times 4 is going to give you 4 over 2, which is 2. And then 2/3 times 4 is going to give you 8/3. All right. And so there you simplified it so that it has rational exponents in the end. You could, if you wanted, turn it back into this. Just so if you could say this, you could say 81 x squared, and then you could say the cube root of y to the 8th, right? So that would be fine too. But the point is just getting us used to this idea of using our exponent properties and also remembering this connection between radical notation and rational exponent notation.